Hi guys, today we're going to solve questions from paper 3, force and its effects. The first question, the figure 1.1 shows the speed time graph for a car traveling along straight road. Speed and time graph. The graph shows how the speed of the car changes as the car passes through a small town. Describe what happens to the speed of the car between A and B. You can see from A to B, the speed of car is reducing, so that we can say the speed of car decreasing. And from B to C, the speed of car is constant, so that we can say the speed of car is constant. What about between C and D? Between C and D, the speed of car is increasing, so that we can say the speed of car increasing. Now, let's look at the second one, B. Calculate the distance between the start of the town and the end of the town. We need to look at the distance when it's entering to the town and leaves from the town between B and C. We know that we are looking at on the speed time graph, which is the area underlined. It gives us the area is equal to distance covered. Distance covered. Now we have to find out the distance. This point is 18 and this point is 42. And then the speed of the car in this between between B and C is 13. How to find out this area? This area find out that 42 minus 18 times 13. 18 times 13, it gives us the distance covered, which means 312 meters. This is the distance which cover between the start of the town and end of the town. Calculate the acceleration of the car between C and D. Okay, we use again the graph between C and D, which is, we know that the gradient of the speed of the time graph, the gradient of this graph between C and D will give us the acceleration of the car. So that, how to find out the acceleration at this point? This is the point we can choose, and I can take the D to find out the coordinates. This point is 31 and this point is 13, and when you come to down there it's 54. I have to find out the gradient. The gradient is equal to 31 minus, we know that this, the distance y and over the distance x. What is the distance y? 31 minus 13 over 54 minus 42. And these ones will give us 1.5 meter per second square. How do you find out the unit? We know that the unit of time second. The unit of speed is meter per second, and that gives us the meter per second square. What is the acceleration? 1.5 meter per second square. State how the graph shows that the deceleration of the car has the same numeric value as its acceleration. When we find out the gradient between A and B, this is the 13, and we can choose this point. The gradient from A to B is equal to from gradient to C and D. Only the problem is only the directions are different. The one of them is positive and the other one is negative. So we can say that they have same gradients. If they have the same gradients, so that they are same each other. Let's look at this question 2. A car of mass 900 kg is traveling at a steady speed of 30 meters per second against the resistive force of 2000 Newton, as illustrated in figure 2.1. The diagram is here. And calculate the kinetic energy of the car. We know that if the car is moving, it has a kinetic energy, so that we have to find out how to find out the kinetic energy. Half mv squared will give us the kinetic energy. So that the 1/2 times the mass of car is 900 kg times v squared, which is 30 meters per second, 30 squares. And the answer will be equal to 405,000 joule. This is the kinetic energy of the car in this speed. Calculate the energy used in 1 second against the resistive force. We know that calculate the energy used means here we can find out the work done. Energy, the energy is the ability to work, so that the work will give us the energy used, so that the resistivity force times distance. And what is the force here? 2000 Newton. What is the distance? How to find out the distance? We don't know that. And so we know that speed, the distance is equal to v times t, speed times t. And so the speed is 30 times 1, which is 30 meter. 2 times 2000 times 30, which is equal to 60,000 joule energy used. What is the minimum power that car engine has to deliver to the wheels? You know, the resistive force is 2000 Newton, and the energy used against to the resistive force is 60,000 joule. And we can find out the minimum power. Power is equal to energy over time. So 60,000 joule energy over the first second, 1 second, it gives us the power, which is 60,000 watts. What form of energy is in the fuel used by engine to drive the car? What form of energy we use? We use a chemical energy. We use a chemical energy, which is the fuel, is chemical energy to drive the car. State why the energy in the fuel is converted at a greater rate than you have calculated in C. In this part, we have to think about the idea of energy of loss. The energy can be lost through heat or through sound. Idea of loss energy. The idea of energy loss. Or heat, can be heat or sounds, loss through sound. The question, let's look at the question 3. 2 students make the statements about the acceleration that are given below. for a given, students A say that for a given mass, the acceleration of an object is proportional to the resultant force applied to the objects. The student B say that for a given force, the acceleration of an object is proportional to the mass of an object. One statement is correct and the one is incorrect. Rewrite the incorrect statement, making changes so that it's now correct. Look at the student A, and we should know that what is the relation between force and mass and acceleration. This is the beginning of the, if we want to solve these questions, we have to know that. What is the relation between force, mass, and acceleration? We know that force is equal to mass time acceleration, so that when a given mass and the acceleration is proportional to the resultant force, so that when you increase the acceleration, increase the force. When you decrease the acceleration, and also decreases the force. The student's A is correct. What about the student's B? For a given force, the acceleration of an object, given a force, the acceleration of an object is proportional to the mass of an object. When we look at here, mass is equal to force over acceleration. If the acceleration increases, the mass will decrease, so that's not correct, which is we have to write it again, because the acceleration is inversely proportional to the mass of an object. For a given force, the acceleration of object is inversely proportional to the mass of object. Let's look at state the equation which links acceleration A, resultant force, and mass m. We discussed it the previous one. F is equal to mass time acceleration. Describe what happens to the motion of an object move when there is no resultant force acting on it. When there is no resultant force acting on it, which means it can be stopped or it can be moved with the constant. It's a moving object, which means it's moving with constant speed. A resultant force is applied to it in the opposite direction to the motion. What can we say in this if it is opposite, if the resultant force is bigger than the driving force, so it decreasing the speed. To decrease speed, or can change the direction. Or change the direction. A resultant force is applied to it in a perpendicular direction to the motion. Okay, everyone can do a mistake in this type of questions. We can say in these questions, the car moves in circle or curve. Okay, let's continue with the question 4. In a laboratory, an experiment is carried out to measure the acceleration of trolley on a horizontal table when pulled by a horizontal force. The measurements are repeated for a series of different forces, with the results shown in table below. A, on the figure 1.2, plot these points and draw the best straight line for your points. Now in this question, we are going to use the table and to draw or to plot the best straight line for these points. We're going to see that, okay, the force is 4. I can use a different pen, which is blue. 4 against, this point. And the other one is this 6, which means 4 and 8. It can be in the middle. Here somewhere else, in the middle between 8 and 4. There is 10 small boxes, which means the 5, it's 6. And in this point, it's in the middle also. We can see 4, again 10 boxes, 2, 3, which means here. This is the, sorry, this is 0.85. Okay, we're gonna find the 85, the 0.85, which is here, and against the 6. And this is my second point. And the third point is from 10 to 1.55. This is the 10. $1.55, which is this is 1.52. If this is the 6, you can see 6, 7, 8, 9, 10. This 6, which means this point is my 1.65, another point. And after that, I will find out the 2.25, which is somewhere here, but against the 14, somewhere here. And now the 4 points, I already put it, 1, 2, 3, 4, they're here. I want to draw the best fit. Okay, all the points, it's not need to be coincides. The best fit should be the best points, which are it's a bit challenge sometimes. You can see there's 3 points. They're exact in the same line. I can use that with a different color, which is I can use a red color. Sorry. Okay, this is my best fit. And which points are good for you? You can choose okay, 1, 2, 3, 4. out of 4, the 3 points are in the same direction, so that I can use them to combine and draw my best fits. So the graph shows that below a certain force, there is no acceleration. When there is no acceleration means, guys, when the acceleration is 0, which is this value? Okay, we have to find out this value. Where is it? Sorry. See, I made a big mistake. It's not good to combine that, but you don't try like that, but it's okay. And to find out this, what is this point? This point should be 1, 2, 3, and make 4, which means that point is around 1.2, isn't it? At past 1, which means 1.2 Newton. This is when the acceleration is 0. When the acceleration is 0, the value is the force. The value of the force is 1.2 Newton. This value, it can be changed according to your graphs. It can be less than 1.2, or it can be more than 1.2. The range is between 1 and 1.4. So a force smaller than that BI is applied to the stationary trolley suggests what happens to the trolley, if anything. If the force, when there is no acceleration, if the force applying to the stationary trolley less than 1.2, what will happen? And nothing happens, remains stationary. Or nothing happens because this force, it's not enough to move the trolley. Okay, show that the gradient of your graph is about 5.7. Let's look at the graph. Let's look at the graph, and to find out the gradient is 5.8. Actually, we have to find out the gradient. What is the gradient? According to the graph, we have to choose 2 points. I can choose these points on my graph. I can choose these points. And this gradient, delta F, the force in changing, over acceleration in changing in acceleration, sorry, delta A, will give us the gradient. And when we find out delta F, we're using the pen, delta F over delta A. What is the delta F? The first point, it was actually 10. 10 minus 4 over the acceleration 1.55 minus 0.50. When we do the calculation, 6 over 1.05, 6 over 1.05, can we do it here? We have to find out the calculator from the tools. Actually, on the maths tools, we can use the calculator here. 6 over 1.05, which is 5.7, incredible. It's amazing. Meter per, what is it? The first acceleration, it was the mass. Sorry, I cannot put here, but we can find. So the gradient is equal. That's great. I can put the calculators over here. The gradient is 5.7. Already we have we found it from the graph. State the equation that links resultant force, mass, m, and acceleration. And we should remember what is the relation between force, mass, and acceleration. Force is equal to mass time acceleration. This is the link. Use your gradient from C to find the mass of the trolley. Okay, we know that the gradient force over acceleration, it will give us the mass. We know that mass is equal to force over acceleration. So the gradient 5.7, it's our mass. What is the unit? We know the force is Newton, the acceleration is meter per second squared, and so the unit is kilogram, 5.7 kilogram. On figure 1.3, sketch a speed time graph for a trolley with a constant acceleration. Okay, when there's a constant acceleration, which means the speed increases with the same rate. This is the graph which is give us the constant acceleration, speed time graph.